Hello. I know you're probably confused right now because this is not your normal teacher. This is Mr. Darty, about to make this wonderful video of 7.2 for you to watch and be able to work on the homework. This could be a good morning video, good afternoon video, or good evening video, depending on the time that you're watching it. So continuing the notes from 7.2, the first step in solving by substitution is you solve one equation for one variable, and then you substitute in the other equation and solve for that variable. So after we have solved for one equation, then we're able to substitute that in to find a variable that's by itself. Then after this, we are able to substitute into either original equation and solve for the other variable. So we'll have, say, x, for example, and then we're able to plug that in for x and solve for y. We can write solutions and check into both equations. Like we talked about in class, we can always go back through, check our answer, make sure we're right. All right, go ahead and jump right into our first problem. X equals y plus 3 and 2x minus y equals 5. See, in this equation, we already have x there by itself. So since x is by itself, I can go ahead and substitute that in for x. Okay. So I'll have 2y plus 3 minus y equals 5. So I'm going to go ahead and be able to distribute the 2 to the parentheses. And I'll have 2y plus 6 minus y equals 5. Okay, so what I did was I plugged in for x, y plus 3, to be able to have one variable in the equation. So now I'm able to solve for y. I can combine my like terms, and I'm left with 2y minus y, which is y, plus 6 equals 5. So then I will subtract 6 to get y by itself, and I'm left with y equals negative 1. So now I know what y equals negative 1. I'm able to go ahead and plug that in for y, right, in the first equation. Plug it in for y right here, okay? And then after I do that, I will be left with x equals negative 1 plus 3, which means x equals 2. So I'm left with 2, comma, negative 1 for my ordered pair. For my being able to solve the linear system by using substitution. Moving on. So actually I want to go back and say something real quick. In x equals y plus 3, that's saying that x is the same as y plus 3. It's whatever x is going to be is equal to that in order to find and plug it in for the x using substitution. Okay, so now let's move on to number 6. Number 6, I have 5x plus 2y equals 9, and I have x plus y equals a negative 3. Okay, these variables x and y are already by themselves and don't have a variable with them. So I'm going to go ahead and subtract the y from both sides, and I'll have x by itself equals a negative y minus 3. Okay. So now I'm able to go ahead and, I know what x is equal to. X is the same as negative y minus 3. So I'm going to go ahead and plug this in. I'm going to plug in the red right here. Negative y minus 3 in the top. So I'll have 5 minus y minus 3 in parentheses plus 2y equals 9. And I'm going to distribute the 5 both terms, and I'm left with negative 5y minus 15 plus 2y equals a 9. Okay, I have like terms, negative 5y and 2y. I'm able to combine those, and I'm left with negative 3y minus 15 equals a 9. Okay, so now I can add 15 to both sides. I'm going to work up here now since I'm out of room, and I'm left with negative 15 and plus 15 cancel out. I'm left with a negative 3y equals 26. Somebody tell me I'm wrong, because I am. That equals 24. I know you all were paying attention and caught that error. Oh, I'm still erasing. Try this again. Okay, so we have 24. There we go. Divide by negative 3 to get y by itself on both sides. And y equals a negative 8. 24 divided by negative 3 equals a negative 8. So now that I know what y equals, I'm able to plug that in. And I'm going to plug it into this equation right here since I have y and x by itself. So I'll have x plus negative 8 equals negative 3. Okay. So I'm going to add 8 to both sides to get the x by itself. And x equals 5. So my ordered pair, my solution for the linear system is 5, negative 8. Okay. Moving on to number 7. Now on this problem right here, I don't have x or y by itself. So since neither one of these problems are by itself, I'm going to have to first get one of the variables, 2x. I'm going to work with 2x plus 2y equals 6. So I'll have 2x plus 2y equals 6. I'm going to subtract 2y from both sides, and I'm left with 2x equals negative 2y plus 6. Okay. I still don't have x by itself. In order to get x by itself, I'm going to have to divide everything by 2. If I do it to one side, I have to do it to the other side. Okay. I'm left with x equals negative 2 divided by 2 is negative 1, so I'm left with negative y plus 6 divided by 2 is 3. So x now equals negative y plus 3. All right. I'm able to plug this back in up here for x. So that'll leave me with 3 times negative y plus 3 minus 5y equals a 25. Now I'm able to distribute the 3. So I'll have negative 3y plus 9. I bring this down, negative 5y equals a 25. So negative 3y and a negative 5y, I can combine those because they're like terms. I'm left with negative 8y plus 9 equals 25. Now I'm going to subtract 9 from both sides, and I'll have negative 8y equals 16. I want to get y by itself, so I'm going to divide by a negative 8 on both sides, and y equals, after this cancels out, y equals a negative 2. That's a weird negative sign. Erase that. Try this again. Y equals a negative 2. That's better. So I have y equals -2, so I'm going to plug that in to my equation over here to figure out what x equals. So I have x equals negative times -2 plus 3. So x, after I change, x equals 2 plus 3, which I believe that is equal to 5. Here's my solution for the linear system is 5, -2. Okay? So now we're able to see how to solve this type of equation, even if the variable isn't by itself. So it's a little bit more complicated process, but I'm able to get one of the variables alone, and then, even though it has a number in front of it, I'm able to divide by the variable. All right, now we're gonna do number 8. I've finished my lunch and I'm back and ready to do this problem. Uh-oh, it's frozen. There it goes. All right, number 8. This is a word problem here. These are the best, most fun problems you can possibly do in the whole mathematical world. So Andrew has $2.10 in nickels and dimes. He has 9 more nickels than dimes. How many nickels does he have? So we want to be able to write this into two equations, two different equations. Okay? So I'm going to break it down, and I'll have the first equation will be he has 9 more nickels than dimes. So I'm going to set this equal to nickels and say equals 9 plus D. D standing for dimes. And N is my variable for nickels. And I'm sure all you geniuses and smart cookies already figured that out. So then my second equation, I'm going to put N plus D equals 210. Okay? Now, I want to figure out how many nickels I have and how many dimes I have to equal 210. I know that a nickel equals 5 cents, so I'm going to turn that into 5 for nickels and 10 for dimes. And voila, we have our two equations. And I have N by itself right here. So I'm able to go ahead, plug that in, and I'll have 5 times 9 plus D plus 10D equals 210. So now I'm able to take 9 plus D and distribute the 5 to both of these. So I'll be left with 5 times 9, which equals 45. 5 times D plus 5D plus 10D equals 210. Okay? So I have like terms right here, 5D and 10D. I'll combine those. I'm going to work up here now. I'll have 15D plus 45 equals 210. Now I'm going to subtract 45 from both sides. So I want to be able to get this 15D by itself. So minus 45. I'll be left with 15D equals, bring my equal sign down, 165. 210 minus 45 equals 165. The 45, positive 45 and negative 45 cancels out. Now in order to get D by itself, I'll divide by 15 from both sides. And I'm left with D equals 165 divided by 15 is 11. I know what you're thinking, and the answer is yes. I did just do that in my head. So I have D equals 11. So I'm able to take this and plug it in over here to this equation. And I'll have N equals 9 plus 11, which means that I have 20 nickels. Okay, so I have 11 dimes, and 20 nickels. Now, if I want to go back and check and make sure this is correct, there's a couple ways I can do it, but one of the main ways is I can go back and reread the problem. And it says that Andrew has 9 more nickels than dimes. Okay, so I come back over here and I look. He has 20 nickels and 11 dimes. 20 minus 11 equals 9, which holds true in the equation and saying he has 9 more nickels than dimes. So that's the easiest way to figure out how I can go back and check and make sure that my answer will work into the original equation. Okay? So these problems should help you be able to finish up your work here. So that concludes the notes for 7.2.